Abhi, I want to talk to you today about Web 3.0 and smart contracts because this stuff's name dropped, but it's really hard to find anyone who's either talking at superficial levels or so deep in the coding that unless you're completely programming it, you won't understand it.
Yep. It's a hard topic. It's a very deep topic. So it's still a up and coming sort of technology. So it's hard to really get a definition that is in the middle there. But I mean, there's definitely a way to explain it. So yeah.
Excellent. So people often don't know that even NFTs, they operate as a smart contract, connecting to a website in Web 3.0 with like the MetaMask wallet. We'll talk a little bit more about it if you don't know it. That's using a signature that's connected to interacting with smart contracts. I do have a programming background. Smart contracts is a little misleading because it's not AI intelligent. In some ways, it's dumb contracts written in code. And
you're completely right. It's pretty much just static code, and it's run across a bunch of nodes, and these nodes have to all come to a consensus. So they all have to come to the same agreement, which means that the code needs to be consistent. It needs to be very static, and that way that all the nodes can agree and come to consensus, right? So that's how the blockchain works. It's basically a consensus of a bunch of machines, right? So that's just how that works.
And the thing to understand when we're talking about blockchain, we're talking generally about distributive ones, not where there's just one point controlling it. In this case,
we're talking about decentralized blockchains.
Right.
Blockchains, a centralized blockchain would be, so one node would be running a blockchain, and that blockchain would control truth, right? Decentralized, the reason why you'd want it decentralized is if there's 3 or 4 or 5 people who are running nodes, then not just one guy can control it. The other 9 have to come to consensus, and that's usually 51% consensus, and that'll validate a block, and that'll introduce that same block into everyone's blockchains, right? So everyone who's running an Ethereum node, or just any blockchain node, all has the exact same blockchain on their node. So just a consensus and sort of like a mutual data across everyone. So
yeah, and this is integrity based on transparency and encryption, not on trust, really.
Yes, and
I kind of trust more.
Exactly. That's the thing. Like with smart contracts, there's no trust, which is why it's more trustworthy, right? You're not trusty. There's no like trust involved because, you're not trying to, you don't have to trust another person. It's a trustless system. The code itself is guaranteed to do something. And that's, you can just operate one way and you get a consistent input to a consistent output. And that's just how that works. It's just a perfect system in that way.
So let's break it down into what is a smart contract and what you need to know about it and what are some variables involved and how it might be applied.
Sure. Yeah. So in Ethereum, I'm going to bring up Ethereum a lot because that's just, standard virtual machine that we could talk about how it runs smart contracts. So basically in Ethereum, there's 2 kinds of accounts. There's one that's the user account. So these are called externally owned accounts. Basically, you and me have our wallets on chain, and these are those accounts. Smart contracts are also an account. It's a type of account that lives on the blockchain. Basically, it's the same. It's transcribed the same in the Merkle tree, right? And these Merkle trees, and I don't want to get too technical here.
Yeah.
So the Merkle tree is basically what the entirety of blockchain is based upon, right? And I'm not going to get too much into that, but we'll talk about that in a little bit. Mm-hmm. So these accounts are stored on these Merkle trees in the blockchain. So basically in the blockchain, these accounts are stored, and there's 2 kinds. One is the externally owned account. This could be an account owned by a person, like a wallet. And it doesn't have to be owned by a person. It could be owned by a bot, right? It could be owned by a robot as well. So these smart contracts are a different kind of account. And the main difference between the smart contract and the user is the user has an address and a nonce, right? So only those 2 data points when it's stored on chain. And the smart contract, the difference is the smart contract will have these other 2 data points called the storage hash and the code hash, right? So when you're creating a smart contract, you as an externally owned account, right, can send a transaction. It's basically you send a transaction just like how you'd send, from me to you transaction, but instead of having a to address, you would have call data or a data that would be transcribed from via bytecode, right? And this bytecode can be interpreted by the EVM and stored there. So there's no to address because you're creating the smart contract. Basically, any transaction that you send without a to address will be considered a smart contract. Actually, it's really cool. And it's pretty easy to create smart contracts this way and transcribe them on chain.
So it's code that has conditions on it that if this is met and that's met, then this or that happens. Is that correct?
Yes. So essentially the smart contract itself. So I talked about a little bit about how to create one or how it's created or how it's stored on chain. But the smart contract itself, it's basically a code. It's basically just a bunch of code. And this can be written in multiple different languages. A lot of people think, it can be written in one, but in Ethereum, a lot of people think of Solidity. Solidity is the coding language that smart contracts are primarily written in. There's also Viper, right? The thing is about this code, it's just the code that you would use, on a normal centralized platform, right? But this code can be like it has APIs to interact with the blockchain. So it'll have data types like address, it'll have like gas, it'll have stuff like that the developers will be able to use and interact with the blockchain, right? So this code can be like, okay, so if I want to store some data, right? If I want to you can basically do whatever you want, but if I want to store some data, I can set a variable and have some data and I could set it there and it'll be there forever. I don't have to worry about it ever changing, ever like being interacted with if I don't want it to, right? So anyone can view it. So basically if you set a variable on a smart contract, it's actually free. So one thing to note is it's actually free gas-wise to call a variable function. So basically, if I want to read something from a smart contract, it's a free transaction. So super cool. And if I want to store or mutate any data on the chain, that is when it will cost gas. So when you're doing something like transacting with another person, or if you're transacting with a smart contract, such as like a Uniswap swap. So we'll get into that in a little bit. But the way that this works is if you're interacting with a smart contract and it's being called, main thing to know is that most of the time, if it's a transaction, if there's changing of data, you're paying gas. If not, then you are just reading it. So that's basically how that would work, right? So
I want to introduce some terms for people, and I like to be the translator of the deeper thinkers. and so if you aren't familiar with, gas is a term used on the Ethereum network for we're going to have to pay something to get the system to do something for us. So it sounds like it doesn't cost us anything in crypto to look and see the contract. It's just if we're going to have the contract do something, then we're going to have to put some crypto, usually Ethereum, up front to be able to get the execution to occur.
Right. So let me explain. I'll explain like gas a little bit. So basically what's happening is when you have a smart contract, right, that smart contract is then compiled down to bytecode. And so a lot of people think that Solidity can be read by the EVM or the Ethereum virtual machine. It cannot. It actually has to be first compiled to bytecode, which then is read by the EVM. And the EVM has these things called opcodes. So basically on a normal computer, on a normal machine, we have very low level registries, like you have add, subtract. So essentially, like if you click on a button on your page, it'll do a bunch of these very low level commands that eventually compile down to your ones and zeros in your computer, right? Your computer can understand an add function, very, very low level stuff. In the EVM, it's sort of similar. Your code and the smart contract is compiled down to this bytecode, and then it is translated into like opcodes. And these opcodes are measured in gas. So basically an add function would be on chain, actually right now, 3 gas. And this is always consistent. So this gas will add up and each transaction you make. So if you make a transaction that costs X amount of gas, like it'll go like add, subtract, store, stuff like that. It'll add it up and it'll have a gas amount, right? So, and this gas amount, the reason why there is gas in the first place is because if you're using the EVM's resources, right? So if you're going to transact something, even on AWS right now, like if you look at centralized services, right, you're using a resource of a server, right? So, and that server, you need to pay the fee for using the server. Essentially, that's why Ethereum, you need to pay the fee to the node provider, saying, hey, you use some electricity, some energy to make this happen. So I need to, be able to pay you, and they can calculate how much computer steps it's going to take to achieve this process. And that's what gas comes from. The gas is basically like saying, oh yeah, okay, so it'll take this many steps for the computer to do in order to achieve this. And it's consistent across all devices. So basically if you're saying, different computers, different nodes will have different, amount of computational power it takes, right? So basically what they'll do is they'll compile it down to this gas and op codes. So it's very consistent across every node. It's very nice. And it's a super good system when you're working with decentralized stuff, right? So, and it'll compile it down. And gas is always consistent. Gas price is what's different. So when you're going on Ethereum and you're paying some Ethereum for a transaction, this will fluctuate depending on node availability, right? So if there's a lot of transactions going through at that time, then there's going to be less nodes available. You need to bid higher for the amount of gas that you're paying. So essentially, your gas price is what increases and decreases, but the gas itself never does. Another thing is, cool. One thing about smart contracts is actually if your transaction fails somehow, that gas, whatever you made the EVM use, you'll still end up paying that. But the transaction could get reverted. But the thing is, your gas is still lost there. So if you're wondering why, if a Uniswap swap fails, then you're actually still paying the gas, like some of the gas. You're just paying for what you've used so far until it got reverted, until the transaction got reverted. So
I'm old school. I grew up with early computers and something even called time sharing. So, that's where with big computers, you were paying for slices of time to use. And I see a lot of similarity. And then I was back in the Radio Shack computers and something called Commodore, really old, but really the basic and other code was being converted into machine language, which is what the computer ran on. And I think this is a similar thing if anyone's listening and old enough to know that stuff, that it's not running on the actual code, but it's converted down. It's going to take so much processing that's dependent on availability and resources. And you're going to pay, you usually want to cover the cost enough to guarantee you'll get it done. Is that correct?
Yes, exactly. Yeah. So basically you're paying for these low level operations, and everyone can measure it and justify a transaction cost for it. And you're able to make that happen, that data exchange happen, and you're able to mutate the blockchain state. So that's basically how that works, and the interaction with smart contracts there.
I want to take a very simple real world example, and then you kind of walk through how it would be done. Let's say I'm renting a room from you, okay? Mm-hmm. And I agree to pay for a fixed price for 1 year, so much ETH, per month. Mm-hmm. How might we set up a contract like that? Where is that, and between you and I'm going to pay my rent in Ethereum, and it's going to be fixed for a time period of 1 year, because you really need to think through all the variables in this, because once it runs, the game's in play. There's no like contact the attorney, let's change the contract, right?
Yes, it's fixed. I mean, there's going to be some nuances in a little bit in the future, because a lot of people, like, it is a fixed. Smart contracts are fixed. There are new smart contracts, EIPs, basically Ethereum implementation plans that are coming out that will change this a little bit. But for right now, yes, smart contracts are like smart contracts that are current are fixed, and you cannot change them. And even in the future too, if you make these same smart contracts, they will be fixed. There's different kinds of smart contracts that are coming out. That's what I'm saying. So basically, yes, if you wanted a smart contract, I would say, hey, you pay me this every single month, this amount of ETH. Mm-hmm. It will basically take the ETH from your wallet and it will deposit it to the smart contract, which then will be dispersed to me, or you could just do it directly from you to me in the smart contract itself. So one thing is in this smart contract, it's the time, right? So on the blockchain, actually, you cannot access time. So it's not like it's not some sort, because time is different for everyone. So
Right.
you want to basically, to be able to use date time, you need to access some sort of API within the blockchain itself, depending on what blockchain you're using. Some also, use APIs, external nodes called Chainlink or oracles. They'll get data from the outside world to the inside. So a lot of these smart contracts that are dealing with outside world data, you need to actually use either an external call or a Chainlink node. And the reason for that, so one thing that's also a property of smart contracts is they have to be deterministic. And basically what it means is every node, and as I was saying at the beginning of this, every node has to come to the same conclusion. So so to validate a block, every node is going to run the same code and it has to come to the same result in order to change the world state of Ethereum. So the reason that this is difficult in terms of with a traditional API is that it's very hard for latency. Like you have latency, then you have some stuff going down, and it's just like the requests can come in at different values. Like it's very difficult. So the way that this is handled actually is a very genius way, almost like Web3. The thing about Web3 that really impresses me is the devs that come up with these solutions are at the top of the game. Like I'll get to that in a second, but the thing is, the way that this is made is you want an API. So you want a node that's on the Ethereum chain. So Chainlink. So you get a Chainlink node, and this Chainlink node will have some sort of call data that you can pass into, and you can get back some data. And this can also be via events. Like there's WebSocket kind of functionality here. And this Chainlink node will contact an external call to its own Chainlink blockchain. And this blockchain is also decentralized. So that's the cool part, because normally this would make it centralized. Like, oh, you're getting data from another centralized source. Chainlink is actually a decentralized source itself that will contact the Ethereum network, which is also, so it'll be a decentralized to decentralized exchange. And they've actually solved the problem of keeping the decentralization even with getting external data, which is it's just so brilliant to me. And even with IPFS, if you're looking at interplanetary file system, this is the way that you actually access files and data on chain. That's also decentralized. Like the way, so for those of you that don't know, NFTs, if you're storing them on chain, you can't store a huge 100 megabyte image on chain. Obviously, that's going to be a lot of data, and to have that stored permanently is very, very expensive. So what we can do is we can, similar to how we're contacting Chainlink, we can contact the IPFS, which is also another decentralized system that they made. And what they did was they basically, your 100 megabyte image, they would shard it into different chunks, right? So it'll combine it, it'll hash it, and it'll shard it into different chunks, into different sections, and each section will be able to contact another section because it'll have that data. It's like, okay, so this data is related to this data here. And because they disperse it, it becomes decentralized. So you're able to, find what data you're looking for on the IPFS and bring it into Ethereum without having to have these huge files and basically call this decentralized data storage, right? It's super, super clean. And I think that something like that, like Filecoin, is the same thing as IPFS essentially. But it's a really insanely good technology that has came into the blockchain space, which I'm really thankful for as a developer, because there's a lot of tools now we can use, because you have data storage, you have APIs, and you have the decentralization of the blockchain, the security, and the validation, right?
So two things I want to introduce. One, API to people who aren't familiar with the term. That's my job. So an API really, to me, is a interface that lets different systems work together based on rules. So you can pull certain data or send certain data, but it's just like a pipeline with restrictions. So you can't steal all the records or something else. Is that a way to describe API? And then the second, I want to get back to our smart contract of me renting a room. So
right. So traditionally APIs, yes. So traditionally APIs are like that. So it's restricted because in a normal scenario, right? So if you have a Twitter profile, Twitter username and whatnot, Twitter has its own API to let developers like me and everyone else basically you look at your user data. So if you look at if you look at some websites, they'll be able to pull up your Twitter information. And the way they're doing that is because Twitter is allowing that data to flow out of itself. So it's saying, okay, you can access our user data and we'll let that be easy to consume for you through an API. And that API will say, hey, I can call for this username and give me that guy's latest tweet, his bio and stuff like that. And it'll spit it out. Basically, it's just it's a data outlet and it's a data inlet, depending on how you use it, right? So, yeah, I mean, traditionally, that's how that would work. In Web3, though, the cool part about APIs, like centralized APIs versus Web3 is in Web3, you don't have to give permission or anything like that to access that data. So if I have a bunch of users on wallets and stuff like that, it's not like I need to create my own outlet and API and to design a really complex system. I can just have, my tokens. So my token owners, I can just have out there as public, and everyone can access the token owners. So this is why on Web3, if you're using authentication, like say if you go to my website and if you go to Martin's website and you have your Web3, your token IDs, your NFT, that same NFT can be used by Martin. Say, oh yeah, you're this profile, this is your name, this is your last name, this is your date. You can use that on your website and I can use it on my website without the smart contract ever having to give us that information. And it's consistent across all websites without having any integration, any sort of, contact between us, right? So say if you own a Bored Ape, Bored Ape website will be able to track like, oh, if you have a Bored Ape, then you can access our website. But I can also create a website like that. And it's like, oh, if you have a Bored Ape, you can access my website. You can access some features and there's no intercommunication with me and Yuga Labs or something like, right? So, and it's a super cool system where devs can be able to collaborate with other projects without having that sort of, mixing of communication, basically. And it's a really interconnected way to use these NFTs. And we'll get to that, of course, later. Probably we'll get more into NFTs, but that's how the APIs basically work.
Excellent. Now let's get back to, I'm renting a room from you. You have let's say you have a rental property and we're hiring someone to set up a smart contract for it. What would that look like? So I say I'm going to pay 1 Ethereum. I'm looking at the conversion rate right now, per month for it for 6 months or something. How would that be set up and established? Because that would be a regular interval contract for one time period a year, and then we renegotiate.
Yeah. So basically, like for that smart contract, you would need a wallet. You need to say, okay, so this is my tenant wallet, and you would send like the tenant wallet would have to sign a smart contract, basically a request that'll say, hey, at this time interval, it will drain the wallet of an ETH, or depending on how much you're paying. Typically with that kind of smart contract, unless if you want to be paying in 1 ETH every year, that's a very hard thing to do. Cause basically I'm saying from a landlord standpoint, right? ETH price fluctuates even for the tenant. ETH price fluctuates. So it's pretty difficult to do it that way. But what you can do is you can actually access the US dollar value of ETH and take the amount of ETH that is equivalent to that US dollar amount at any given time. So say if the next month, $700, Ethereum's worth $2,000, I'll only take $700 worth of ETH. Same with the next month, $700 worth of ETH, right? And you can actually do that via Chainlink very easily. You could say, what is the US dollar value of ETH? Because the blockchain itself doesn't know it, but Chainlink will. And you could just say, hey, Chainlink, what's the Ethereum value right now in US dollars, and just take that amount out of your wallet, right? And you can sign that and have it connected to the smart contract, and that'll be there until there's possibly a end contract method on the smart contract that'll be like, hey, we're ending our contract, and this is the end of the term, or there'll be a multi-sig, or even like the landlord wallet can sign off on a function that'll be like, hey, let's end this contract or something like that, right? It could be a mutual thing too. Like I can give the tenant a tenant's wallet access to end a contract. And once you end a contract, you're basically saying, okay, well, I'm done paying or something like that. Like if you're doing a month to month, obviously, month to month contract, obviously, if you're doing a lease term of a year, then you won't allow the tenant to disengage that contract, right? So,
or you could say, unless conditions approved by the landlord or something like that.
Yes, exactly. So basically, both of you can sign it. Say like both of you can sign that transaction for that call, and if that happens, then we end the contract. So there's different ways you could do it, and this way you'll be able to basically see, even like if you're reporting to the IRS or something like that, you'll be able to see every transaction. There's no like Venmo or Zelle kind of thing going on where it's kind of sketchy, because right now I know that a lot of Zelle and Venmo IRS situations are happening where we're getting called out if you're above $600 on a payment, right? So they're calling out landlords. They'll be like, okay, this is sketchy. On the blockchain, it's all like right there. It's like, this is how much my tenant paid me, and this is exactly, like, you could see the transactions flowing from A to B.
So then what we have is somebody's writing out the code, and so you better get someone very meticulous and accurate and trustworthy to generate the code. And that's something,
Yes.
you really take passion in, from me talking to you before, of accurate, well done code. So you got to get the code written correct. Then you have to have the conditions done correctly so that this is what's going to happen if this occurs over this time period. And then it will go out to find out the intervals, because you're saying the blockchain itself, Ethereum, doesn't have a clock or something on it. So it's going out to oh, this is the first of the month. Now I need to execute this. This is what I do. And then I have permission to pull such and such. And you all... Is that right so far?
Right. Yeah.
And then the other piece is this idea of signing. And I think this is another paradigm shift for people. I've been learning.
I have to explain that, yes.
And I have, like, I'm looking up in my browser, I've got my cute little MetaMask that integrates with my browser that will give me permission to sign. And so it's like there's a digital signature that to me is far higher in integrity than a hand signature, because you could forge my hand signature, but it's going to take the end of time virtually to falsify my digital signature. So when I sign a contract with my wallet, that's me. No bank controls that, no one else. If I hold my mnemonic phrase and private keys and so forth on that, it's just me and you.
Yes.
So that's another aspect.
Yeah. So I can get into that as well. And let me get into the initial statement first, where you're like, yeah, you need smart contracts need to be developed by people who really, really know what they're doing, especially because most of smart contracts are dealing with financial objects. So you're dealing with either transactions via tokens that have financial value, right? So this kind of stuff is really important. You see all these people getting hacked these days. So especially smart contracts. The thing about smart contracts and Web3 is, and the reason why a lot of developers like to compare it to the older days, is because in the olden days, these standards, right now, JavaScript, these coding engines are basically have been developed for decades now, right? So, the standards for JavaScript, like, okay, exactly what clean code looks like in JavaScript. You'll know what the highest standard code looks like. In Solidity, there isn't that kind of standard yet. Although they are creating really, really fast, good standards, it's still not there yet. Like with all the new stuff, innovations happening in Web3. So in coding, there's time complexity and space complexity. Basically, it's how much computational power you're using to achieve the same function. So one developer can, have like a script of hard-coded brute force kind of a brute force kind of function that will be very, very hard on the machine, but it doesn't matter because machines these days are so powerful. They're so powerful that even a brute force kind of method versus a very well-designed, using less CPU intensive code, there's not that big of a difference in terms of latency. It's like a few milliseconds, if that, right? So But in Ethereum, it's bringing back to the old method where developers have to be really on top of their game. They have to be like, you have to be very, very efficient, because even one variable declaration difference. So if you look at it, I've even tested like a constant versus a variable. And this is a data type, and I'm going to get into data types. So basically a constant is data that cannot change. It's a variable that cannot change. A variable can change. So, you can change the data, you can change that will change. A constant versus a variable, if you call that gas wise, or storing that just gas wise, it'll cost $7 to $9 more, which is crazy, because in a transaction call, you don't want that kind of, each call to happen. You don't want that much of a difference for your users to pay $7 or $9 extra for just some stupid, just a variable difference, right? So you want to make sure your contracts are very gas optimized. So the skill curve from Web 2 to Web 3 for devs now has went from here to here, because the skill curve is insane. To get to a very a beginner level Web3 developer to a high-end web developer, you need it's very, very skill curved, because not only is you need to make your smart contracts secure, you need to make them very gas optimized, right? So that's something that in the Web3 space that is very new. And there's a reason why a lot of people compare it to the days of old, is because there isn't really the standards yet in place, and developers now need to code at high optima, right? So you need very, very clean and extremely good code. And so to get to your point on the MetaMask and signatures and keys, so what's happening, right? MetaMask is a in-browser, kind of like a wallet. You can use it as a wallet in browser, and it has an API that allows a lot of developers on Web3 use on their smart contracts and their websites to call these smart contracts. It has very easy to use API, so a lot of developers use it. And MetaMask has the ability to store your private keys. What private keys are just a very large random number. Anyone can create private keys, by the way. You can just type in, I want a random number, and that's your private key right there. You can go into the blockchain, use that as your private key. Now, this private key should be basically derived from a cryptographic way. So basically what happens is, in cryptography, the basis of all blockchain and crypto is this elliptic curve signature, right? So what's happening is you have a point on a graph, and that point needs to also align with another point, and it'll be like a private public key kind of interaction, right? So your private key, you pick the point, and then your public key that is derived from that private key can be created. But here's the thing about this cryptography stuff, and it's very complex math. It's almost like it is incredibly complex, and it's something that takes years to understand. But on a high level, what's happening is essentially your private key should be able to derive a public key, but you cannot get from your public key back to your private key. So someone who has your public key should not be able to get back to your private key, but your private key, you should be able to derive a public key. So that's this dynamic, right? And the public key, from the public key, you can actually derive an address. So what an address is, it's basically a hash of your public key. In Ethereum, the hash function would be Ketchak 256, and that's the standard. Ketchak 256, your hash on your public key, and you take the last 160 bytes, or bytes or bits. I forgot which ones, but you take your last 160, and that becomes an address. So now your address on your account is this 160 bit or 160 byte phrase, and you will say to interact. So when you have your MetaMask wallet and you're creating your wallet, this address comes from your private key, which then comes to your public key, and then it comes to your address. Now you can go from your address. So the way that the blockchain works is your address can then you can derive your public key from your address, and basically you can say, oh yeah, so this is my public key, and I can derive my address. Sorry. So what's going to happen is, why this works is because you cannot backwards derive your key from your address. It's very safe. You cannot, unless as you were saying, it takes it will literally take millions of years, like almost to the end of time, to calculate it backwards for computers at the moment, right? Now there's
challenge that even quantum computer may not be able to easily hack this stuff too, but that's a whole nother conversation.
Exactly. Quantum computing can break this at a certain level, but it's not even normal quantum computers. It needs to be at qubit levels of like 2,500 plus, which we're not close to yet. Right. But it's dangerous. It's definitely something to watch out for. I'm going to write an article on like what is, the interaction between quantum keys and how it can break hashes on Ethereum and even normal networking. A lot of the high end, like central banks are now, I work at a big bank. So, we're working on quantum, we have to be worried about quantum data hacking and stuff like that. Blockchain more so. And I'll explain that in an article at a later date.
We'll put it as a link.
Very deep subject actually here. So basically when you're going through this private cryptography, the elliptic curve cryptography is basically how this all works. So when you sign something with your private keys, you will be able, the signer or the verifier will be able to tell, hey, this is coming from this account, which is a really cool thing in cryptography. And this is the basis of all blockchain, of all cryptography. Basically, it's that we can backwards verify, but we cannot backwards derive. So you cannot derive back to your private key, but you can verify that this private key was the one that signed this data. So that's the beauty of this, right? So on your MetaMask, when you have your private keys on your MetaMask, all it's going to do is when it comes in with some data, your private key will sign that data and then hash it, and it will go out to a validator or a verifier, and it'll be sent to a Geth node or a Ethereum node. Probably not. I mean, there's other kinds of nodes, not just Geth, obviously, but Geth is the most popular one. I think it has like 51% share of like the amount of the node type of nodes. And that's something that's a little bit more technical. And basically what I'm saying is it'll get from your MetaMask will be able to access a node on the Ethereum chain. And it's a very easy API. It's very user friendly. So it'll say, okay, so let's sign this data. It'll pop up with the browser clickable event, and it'll be like, hey, it'll show you the details of the signature and the transaction fee. So one thing that I want to make sure that everyone understands is when you're signing this kind of stuff, you could accidentally sign away some crazy stuff, right? So you have to be careful on chain. There's a lot of hackers and scammers. This is still we're in the early days, so it's very difficult for people to differentiate. But there's ways to do it, right? So, you're able to differentiate a hack, something that could drain wallet funds versus something that's an actual legitimate event, right? So, and you don't want to give your wallet access to any random websites, or you don't want to keep your private keys on your MetaMask, actually. So this is something that I want to explain to everyone. MetaMask is the safest way to interact with the blockchain if used properly. So if you have your MetaMask and you have your private keys on your MetaMask wallet and it's in browser, it is actually very dangerous. The ability for a hacker to access browser events or injected browser events such as MetaMask is pretty fair game. Like, it's pretty easy. There's hot wallet hacks going on in Solana where people are able to get access to the hot wallets. And that's obviously very bad for you. So MetaMask, what you can do, what the most optimal way to do this is, you want to store your private keys on a hardware wallet. A hardware wallet is an external wallet like Trezor, like Ledger Nano, and these will be able to store your private keys. And here's how this works. So when you get an Ethereum transaction request on your MetaMask and you have your hardware wallet connected to MetaMask, on MetaMask, it'll show import hardware wallet. It's, when you add wallet, it'll say import hardware wallet. It's pretty easy to set up. And when you set that up and you get a transaction request, it's going to get the transaction request and you have your private keys on your hardware wallet. So it's never touching the browser. It's never touching an online source. What it's going to do is it's going to send that data, transaction data, to your hardware wallet. The hardware wallet has the tech inside of it to do that. And then the hardware wallet will only sign it, and it will never let the keys go into the browser. So basically it'll sign it And the only thing that leaves this hardware wallet is the signed transaction data. And that would be sent back to your browser. Your browser will be able to take that transaction data, send it to a Geth node, and that node will be able to, mutate the blockchain based on your transaction. So this way is actually the safest way to interact with the blockchain if you're looking for a hot wallet solution. So I would recommend, and the reason why this is so secure, of course, is because when you're signing data on your MetaMask via hardware wallet, on your hardware wallet, you have to physically type in like your passcode. So it won't like just automatically drain your funds off your if you're connected on MetaMask and you're like unlocked, you have your wallet unlocked on your MetaMask, right? So it won't accidentally do anything like that. You'll have to physically approve the transaction, so no one can just drain your wallet of funds unless if you literally sign it away. So that's another thing, obviously. Even if you have this sort of setup, if you're interacting with a smart contract that's a devious smart contract, you're getting hacked either way. So you need to make sure you're able to go on chain and see what these smart contracts are doing. And a very good way to do that is Etherscan. So if you're on the Ethereum network and you are able to get this smart contract address, you can actually just paste it in on etherscan.com, and it'll show you on the functions calls, it'll show you exactly what kind of functions are in this smart contract. Now, this is a little bit technical, but unfortunately, this is really the only way that is warning you that you can get yourself a little bit more info on the smart contract before interacting with it. So you're able to see some of what's going on in the functions, and it's a very easily digestible way for people who are a little bit more tech savvy than the normal person. But I think MetaMask is introducing some new features on their front end as well, saying like, hey, this is a transaction that's taking funds from your wallet. Are you okay with this? Right? It'll give you some user interface warnings, which is really nice. I think that they're doing some really cool stuff to MetaMask to update it. But essentially, MetaMask is a UI, a guided user interface that will help you transact with the blockchain. Like it'll help you connect to the blockchain, right? So when you're working with applications, as a developer, you're interacting with a JSON RPC node like on Infura or something like that. MetaMask is the same thing, but it will straight up, talk to the RPC node, which, as I was saying, is the Geth node, and it'll talk to it like an Infura node, and it will transact to the blockchain. It'll just do it on the back end, right? So it's just you won't be able to see it, and that's what's hidden behind what the user's seeing. It's not that much, really. You're just sending your transaction data, your signed transaction data, to the blockchain essentially via MetaMask sending it to a Infura node.
Extremely exciting. Now, I want to add a caveat. Your job is to be as accurate as humanly possible, almost like a security person. I want to say another possibility when people are learning and playing is just limit what's in the MetaMask wallet. If put no more in than you can afford to lose. If you burn $20 and you're going to be devastated for a week, don't mess with this. So I just want to introduce that because I'm always thinking from the non-techie interface. It is quite a few extra steps, like the system that I've worked with, the Locust DAO. That's really working with, allows people in fact where he's going to airdrop some coins to you and then you're connecting. Well, just don't put all your money in your MetaMask. Keep it like you don't walk out the door with $1 million. You got a little bit in your wallet. And if you're a big city, you go, I'm not going to have any more in this. Then if I'm held up, it wouldn't ruin my day to be robbed,
Yes, exactly. And
so
actually,
I do want to add that to let people at least play and learn about it, because for you, the extra wallet, I have it. I've got a Trezor and some others, both of them. But for you, the person a little more techie, that's not as hard. But someone who just wants to start playing and maybe connect to a few things, just don't transfer any more into that MetaMask so you can afford to lose.
Yeah, exactly. And actually, that's a good point you bring up, because we could talk about cold versus hard or hot wallets, right? So basically what you want to do is, as Martin was saying, you could have a burner wallet. Mm-hmm. When you're interacting with smart contracts, you only want what you need, exactly the amount you need when you're interacting with smart contract in that wallet. So you don't lose anything else. You don't have all your NFTs in there or anything. You put your NFTs in a colder wallet, or in a hard cold wallet. So basically what we're saying when we're talking about cold wallets are Cold wallets are ones that are not connected to the internet at all. It will never be connected. It won't, be connected. It'll be something like you have Bitcoin and you want it to just be there, and you don't want any hacks to happen. So you just literally leave it as inside of a Trezor wallet or something like that, in another Trezor wallet, or inside of another Ledger wallet or something like that. Some people even like to do paper wallets, which is just storing their keys on a piece of paper and just having it in some sort of lock safe. And that is a wallet right there, because essentially you can just enter that wallet in whenever you need it, and you will be able to connect to the blockchain and make transactions there. But until then, you can just leave it as a piece of paper, and just leave it in your safe or whatever, right? So you have different levels of security risk management you could have when you're interacting with smart contracts in the blockchain. And I think good risk management is, if executed properly, it's almost perfect. You'll never get hacked. You'll never be scammed. It's very, very low risk. So a lot of people are like, oh, but there's a lot of scams and hacks going around, as I was saying, like in Web3, but there's very easy ways to counteract the scams and Web3 hacks. I've never been scammed or hacked yet. But the thing is, I know kind of how everything works, and I properly manage my risk, and it's very, very easy to, move around and maneuver in this Web3 space without being super damaged, right? And even if something does happen, you can, as a burner wallet, whatever. I mean, you just lose a couple like $20 worth of ETH or something like that, and you're like, okay, well, whatever, right? So that's another thing, like cold storage wallet versus hard storage or hot storage wallet. A good thing is when you have these keys, so it'll give you a mnemonic phrase, and that mnemonic phrase essentially, as I was saying before, with your private key, right, it's just a bunch of numbers. All that mnemonic phrase is, the dog will translate into a group of like 4 numbers or 4 random numbers, and that will be stored on a dictionary in public somewhere. And your dog cat mnemonic phrase will just be encoded into these numbers, and it'll be concatenated together into making your private key. So that's just all it is. And with that private key, you can actually derive a bunch of your addresses. So if you look at your Trust wallet, you only have one private set of private keys, or your MetaMask, but you have a bunch of accounts. You can have accounts on, Polygon, Ethereum, Binance, and stuff like that, but they're all derived from the same private key. That's the thing. That's the cool part about this, is that it's just using different hash functions at the end to derive these addresses, but it's using the same private keys. So you can access all your accounts using the same private keys. It's a really cool way that they implemented it in blockchain. It's really nice that you can use the same private keys for all the different kinds of blockchains, So I think that's pretty cool. And that's basically what's happening on the back end, right? A cool way to store your private keys, actually, that I found, is if you have a favorite book or favorite poem or something like that, and you're like, okay, so I don't want to, if I store it out on paper, if I store these mnemonic keys on paper, somebody might take it, right? You could flip one phrase to the other, and that you flipped, the first and the last word in your head. So if anyone ever gets that piece of paper in your vault, they'll be like, okay, well, let's type this in. It's not going to be your private keys, but that you flipped those. There's another thing that you could do, is you have a book or a poem, right? You could actually you could say line 43, page 102, right, of Harry Potter. Mm-hmm. And that word on that line and Harry Potter in that edition, right? No one will know that the book is Harry Potter that you're referring to on that line. So if there's a word like dog, if dog is in Harry Potter at like page 100, line 103, and that's your favorite book, and that book, no one will ever guess. Even if they get a hold of that paper, they'll never know that's your word, because you're like, line 103 and like column 43, like, I don't know what book that's going to be from, right? Like that could be anything. So, but you'll know your favorite book. So that's a good way to hide private keys. Even if they get an access to it, you'll be able to have it in your head. So
excellent. In fact, I'll just hold up. This is like one of the Trezors not plugged in, and
yep.
And then it's a hardware one, and it gives something that it's controlled offline. You plug it in when you want to use it. You can disconnect when you don't. It's not going to lose anything. And then the mnemonic phrases come from a fixed, limited dictionary that they can pull off of. And then, you can either put it in metal or a fireproof bag in your safe or something. I'm just giving you a few quick ones for those.
Yes.
So those are a few. So we've done an introduction, and I know many of you are probably overwhelmed with it. You'll probably have to watch this a few times to get it, but that's what I wanted, a little deeper dive introduction on smart contracts. It is something you want it to done correctly. You want someone like yourself that's really studying and getting into what does it take to create highly accurate content and all this, and make sure you're working with trusted people with it, like yourself. And the next thing I'd like to talk a little bit about is Web 3.0 from a technical aspect, because my friend's working with this thing called the Localist DAO, and I'm involved in it. And, you know, when it comes to voting or any accounts or moving money, I connect my MetaMask to it. It signs in under me, and that's just me talking. And there'll always be that record of it. And I'm kind of hoping you'll get excited enough to play with us, because I'm sure he'll drop a connection so we can get you playing around with it as well. But let's talk a little bit about this world of Web 3.0, because it's Pat likes to say one way to word it is it's a distributed blockchain internet system.
I mean, governance is something that's super basically it's super useful in blockchain technology because it's true governance, right? Like if you're working with a centralized system and you have centralized servers that have all your votes and stuff like that, I can just go into the database and change that number. Like I can say like, oh yeah, 50 people voted for this. No, actually like 400 people voted for this. Just literally type in the number over there. Now with governance, it's like, oh, well, this many wallets voted for this. You see how many wallets voted, who has like what kind of share. So normally governments would work like one wallet for one vote, but some people have systems where it's weighted votes, right? So if someone has like X amount of tokens of this kind of token or an NFT, then they get extra votes. So they're like, okay, well, if you have a lot of stake in the network, then you're going to get a bigger vote, of course, right? Because you have a lot more to add or lose. And it depends on like some governance systems work like that. Some do one for one, from Vault wallet. But the thing is, so the other thing is the reason why the wallet stuff is kind of weird, because if there's no collateral or stake in the matter, is you can just have code. I can run a code that can just generate infinite wallets or like 1,000 wallets and just completely overflow your governance and say, okay, well, I have one, I just want one vote here. Mm-hmm. But so that's the reason why these weighted governance systems works, is because, if you have an NFT or you have to hold a certain amount of tokens, it's not possible. Like it takes a lot of monetary stake in order to actually, influence the votes, right? Influence the votes via code or something like that. That's basically how proof of stake actually works too, right? So validation and we'll get into that, but that's basically essentially how governance works in proof of stake as well. So
yeah, so when we say interacting with Web 3.0, we're generally going to be using a wallet to interact with it.
Yes, your wallet is your main identity to the Web3 space, your account, right? As we were talking about, your account is you on chain, and it will always, you own everything on that account. That is all yours, right? No one else's. And you can take that account and, interact with anyone, anywhere, without having to face any like discrimination. Like, no one really knows, like it's pretty much, it's an anonymous way to interact. And it's very nice. It's just a super clean way to authenticate someone, right? So, yeah. And basically, like in a centralized way, in a centralized application, you're going to have your username, your profile and whatnot, right? On a Twitter, say, right? And as we were saying, like, on Twitter, your information is like that, but on somewhere else, it could be completely different. Like you could be, a name, like your birthday, you have to keep typing in your birthday, your name and whatever, right? On your blockchain account, you can have that, but then also, you can also, everywhere you go, your profile is the same. So, that's you everywhere. And it's really a cool way of authentication and identification, I guess. Right. So
when we do our talk for professionals on cryptocurrency, I go in some of this, it's sort of like we're looking at the horse and buggy versus the first gas engines. The horse and buggy still looks very viable because you don't have to have that oily black stuff and have places to distribute it, so it looks like the horse and buggy is a better transportation. But what ultimately happened is the vehicle over 50 years then evolved into a much more efficient method. And in some ways, I think we are in that. And that's what's so exciting, because we could have voting where it'd be virtually impossible to fake vote, And I think it's so important professionals start dipping their toe in this so they're at least in touch with the future. Because I'll often tell professionals in my hometown, I'll talk in Raleigh, 4 out of 5 young people, they know what crypto is. They probably have some in a wallet. And then they go to a financial advisor that goes, oh, it's dangerous, run from him. And they'll go, well, I shouldn't trust this guy. He's an idiot, because he doesn't understand calculated risk in the new generation of the world that operates. And this is why we developed the whole professional training programs. I'll give another example in this to talk about is like the Brave browser. It's one that you can connect your wallet to and earn some cryptocurrency on.
Yeah. So you're saying like the Brave browser, like how how the Brave attention token works with its sort of network, right?
Yeah.
So I have Brave browser, and I actually recommend that. That's a really good browser. Actually, that's a good browser to use for Web3 in general, because it's super safe. It's actually much safer than Chrome.
Mm-hmm.
But yes, so Brave browser has this thing called Brave attention token, and it's basically a token that is dispersed to incentivize people to watch ads, right? So if you have, in Google Chrome and whatnot, you're watching ads and it's not really benefiting you at all, right? It's not really like, it's just there as like a hindrance. And sometimes it's, they target you and they'll like make you spend money through targeted marketing campaigns. Whereas in Brave, you as a user can opt to say, and you use ad block on normal like Chrome and stuff like that. But on Brave, the Brave attention token will incentivize you to watch these ads and pay attention and be like, hey, this is a really cool ad. Like I like this, or like, you just watch a bunch of ads that are targeted towards you, and you are consenting to this. And you also get these tokens. So these tokens are worth monetary value, and you're actually getting paid to sort of, browse. Like you're browsing your internet, you're browsing your websites and whatnot, and you're getting paid to do that. It's actually really cool. So like, as you're passively going through, you can get money and get these Brave attention tokens. Vice versa, these Brave attention tokens can be used by advertisers to do the payment to advertiser stuff on the browser, right? So basically, you get these Brave attention tokens, you can sell them. These advertisers are the ones that are going to buy these tokens and then market their stuff. And then some of those tokens are then dispersed to you, the viewer. It's a really cool system. I think it's like, it's one of the things where, Web3 benefits all, right? It's kind of like that. It's the exact same like kind of premise. And I love that it's giving back to the viewer, giving back to the person who's potentially viewing this stuff, and the people want to view this stuff, right? Instead of like on Chrome, you're not really interested in the ads. You're like, well, these ads are doing nothing for me. So on Brave, at least you're like, okay, well, I'm fine with ads. Like I'm getting paid to watch these ads, like, and you'll pay attention and you'll be like, oh, this product actually seems like a cool product. So, obviously in Chrome, you'll see that too, but your attention is not there as much as in Brave. So
no, you have ad blindness to it. It's just Forbes that is got it. It looked like what I call something called the National Enquirer. It's like blinky stuff, and my mind's going, "How do I shut this out and get to what I want to read?"
Exactly.
So now you're anchoring in a negative experience to me with that product.
Yep.
And YouTube's now gotten that terrible with that. I have to watch 2 stupid ads to just see what I want. Why don't you give me a token? Why don't you do some profit sharing here? And now we'll talk. If Google, you're paying attention, I recommend hiring this guy for this. I'm sure there's a price you'd be open to working with him.
Yeah, sure. But there's also another thing that, like you see now, like Hulu and Netflix are losing a lot of subscriptions,
right?
So they're switching to a free, advertising model, right? So, they're playing free but with ads, and this is another thing that it's in general, advertising and marketing can use this kind of methodology to keep users' interests and be like, hey, like, okay, this is a way more effective way of marketing. Where if people want to check out these products or check out these advertisements, if they're like manually checking off, oh yeah, I want to see these, then it's a lot more effective, Another thing is, this way is another thing that, like, within the decentralized Brave network, right? If a lot of stuff these days is getting censored. So, if you're from a different political view, or if you have a different political view of the norm, then you are getting censored completely. And the way that this decentralized advertising works is advertisers will not, advertise on content that, they don't like, right? They don't like this kind of, and they'll
Right.
blanket ban all these kind of other political views, other moral views, or something like that. Whereas in Brave, the advertisers themselves can choose, like, who they advertise to and stuff like that. And it's a very decentralized way, and it won't really affect that much. I'm pretty sure there's some sort of system in place there for that, but that's just how that works. And it's a much cleaner, less democratic way, like kind of like, how it's just less Democrat Republican bipartisan way, right? So
of course, right.
It's super, it's just super everything, right? You are advertising everything, and it's equal, basically, right? So
yeah, some of us still want to think for ourselves and actually want to know something they disagree with instead of block it. We've covered so much. I think we've opened conversation. I don't know, we closed all of them. So I want to make sure this opens the door. And I'm going to ask people, if there's a question not answered here, put it in the text below, and I might be able to get you to come back and we can do some more. I want to do a series with you. This is exciting.
Yeah, for sure. This is super cool. I always love to discuss about Web3 and how things work. And as I deepen my understanding as well, I can come back, share like even more stuff, like of the newer stuff. There's crazy stuff going on, like layer 2s, now layer 3s, ZK snarks, like zero knowledge, like proofs, really, really cool stuff going on in the blockchain space all the time. As I was saying, there's new kinds of smart contracts now that you can change up, like, and we could discuss some of that, like some of the new stuff that's coming up, the cutting edge, because DeFi and DApps and DEXs weren't a thing until like at the beginning of Web3. Now they've become, like, NFTs are big. Like, these didn't exist before, right? But now they're existing in the Web3 space, and there's newer stuff that's coming out every single day, and it's super exciting to learn about and talk about. So definitely, if anyone has any questions, I can come back and answer them.
Yeah, we'll make another show. I just want to say you're my hero. I have a computer science degree, but don't try to get me to code. We're talking Fortran, basic and stuff like that. But the key is to find someone that has the courage to attempt to interface and communicate and also learn, and the generosity of your work. I just want to be invited to your island one day when you own it, because I want you to be the owner of whatever you want one day. It's so hard to find. They're either committed to, I'm afraid if I share something, that I'll lose, which doesn't build any trust with them, or they're not willing to work with someone understanding. And I know we covered a lot of terms that many people may not be familiar with, but, break those down in questions, and we can do other shows on them. And that's why I was so excited when we met, because you have a passion for it. You see how it can truly help the world and add value to people's lives. And 2, you're a work in progress, and you're working hard to learn it. And you don't have such a fragile ego that you go, I'm not sure, I need to research that now. And I'll tell you, if I was hiring a programmer, you're the one I want on the team. Can play well with others, smart, and willing to learn what they don't know. When I was at IBM in field support, the manager says, just having someone technical isn't good enough. I need someone who can work with the team, communicate, and handle problems with the customer. And that's the person I'm willing to pay the top dollar for. So I think this is a wonderful piece. I'll let you end with whatever you think would be a good wrap up. Our goal was to at least introduce a little deeper dive on smart contracts, and I think we did it. And then I'll put links to information about you in the text below.
Sure. And again, Martin, like, I appreciate everything, everything you do. I know, like, you try to, like, you putting on these shows to educate other people about Web3. That's super cool. I don't have a platform myself, but that is super cool that I can talk to someone who does, and, like, just discuss about Web3 in front of everyone, because it's something that's really, really important. we see companies like BlackRock, like the people who pretty much lead the world now coming into the space. It's really exciting. Trillions of dollars just like literally sitting there. So it's going to be something that a lot of people are going to be paying attention to in the upcoming future. And I think that everyone who arms themselves with the information now early on is going to really benefit them in the future, especially when the world changes to a new system. So, Web3 is still a work in progress. And as you were saying, like, yeah, everyone's a work in progress in the Web3 space, right? Because we're still building it, right? So, and I hope to learn as much as I can. I will never say that I'm, the best, because if you say that you're best, you're compliant at that point. I don't want everyone to be compliant with my skills. I want to always be saying I don't have enough skills, and I'll, keep improving. And that's basically my mindset on that. So I love the talk, and just really cool to be here. Thank you so much.
Yeah, this was great. And folks, remember to check the text below and subscribe and hit the bell so you'll see future shows. And let us hear what you want us to discuss next time. This was just our first interaction. I knew when I met you, I was so excited. I've told everyone, and I'm glad you're connected to my stepson, Emery. He's in that. He's just bought 4 more books in mathematics, and I can't even quote what the term is, but it's something to do with AI. So
I'll have to discuss with them on that, on some of this stuff. It's pretty cool.
Excellent. Well, thanks again.
Yeah, thank you so much.